Okay, it says to use the log properties to fill in the missing parts. Remember that each row, every expression is equivalent to the other expressions. So remember, the product property basically says that you can turn like that the sum of two logs of the same base is the same thing as the log of the product. So if log base 3 is 60, that's equal to log base 3 of 6 plus log base 3 of 10, because 6 times 10 is 60. And if you change it to log base 3, it's the same as log base 3 of 20, because 20 times 3 is 60. And then the quotient property says that if you subtract the logs, it's the same as the log of the quotient. So log base 3, 120 minus log base 3 of 2, because 120 divided by 2 is 60. And then log base 3 of 240 minus log base 3 of 4, because 240 divided by 4 is 60. Okay, and then here just like make up your own. So like 36 is divisible by, so whatever this log base, you have to keep that throughout all of these 4 problems. So it's log base 7. And then you just have to manipulate 36. Like, what's a product of 36? 12 and 3. So then you go 12 log base 7, 3. Log base 7, another product of 36 is 6 and 6. So 6 log base 7, 6. And then something you can divide by to get 36. Right, 72 and 2, so log base 7 of 72 minus log base 7 of 2. Or 180 and 5, so log base 7 of 180 minus log base 7 of 5. Okay, and then this one says log base 6 of 9 plus log base 6 of 2. That must mean, so you add them, so then it's log base of their product. So it's a log base 6 of 18, because 9 times 2 is 18. And then you just can come up with another one, 6 and 3, so log base 6 of 6 plus log base 6 of 3. And things that divide, 36 and 2, so log base 6 of 36 minus log base 6 of 2. 54 and 3, log base 6 of 54 minus log base 6 of 3, because 54 divided by 3 is 18. Okay, look at this one. 75 minus 1.5. So remember, then it's the log of that quotient. So 75 divided by 1.5 is 50. So log base 25 of 50. And then you just need to come up with new ones. So 50 is divisible by 10. So log base 25 of 10 plus log base 25 of 5. And then 50 is divisible by 25, so log base 25 of 25 plus log base 25 of 2, because 25 times 2 is 50. And then here you can do log base 25 of 100 minus log base 25 of 2, because 100 divided by 2 is 50. So it's log 164 minus log of 4. So then you do 160 divided by 4, just 40. So then it's log 40. And then just split them up, like 40 is divisible by 10, so log of 10 plus log of 4. 40 is divisible by 8, so log of 8 plus log of 5. And then you can divide 80 by 2 to get 40, so log of 80 minus log of 2. Okay, so obviously, like, you might have different answers than me, but you get the general idea. So it says rewrite each equation as equivalent using log base 10. You do not need to calculate a numerical answer. These are sometimes known as change of base problems. So remember, so you write log, and then the base of the log is the number on the bottom. So remember, those are both b, so maybe that'll help you. So log 2 is the base, so log 2 goes in the bottom, and then this one is on top, so log 3. Then this is log 5, oopsie, I messed it up, log of 8 over log of 5, again, because base, bottom. Log of 12 over log of 7, base, bottom, right, and then log of b over log of a. Okay, it says solve each of the following equations to the nearest point. 0, 0, 1. So x is an exponent, so we need to take that down. So let's just take the log of both sides. So we'll just do that. Log. I'm just going to do the regular log just because I'm feeling a little lazy. So it's x minus 3 times log of 5.825 equals log of 120. And then you divide, you get log of 120 over log of 5.825. And then you can just do that on your calculator. So log of 120 divided by log of 5.825. Right, you got that number, 2.716. So x minus 3 equals 2.716. And then you add 3 and you get x equals 5.716. This one you should divide by 18 first. So you get 1.2 to the 2x minus 1 equals 50. Then just take the log of both sides. Right, the exponent comes down. And then you have 2x minus 1 equals log. So now divide both sides by log of 1.2. And then you have 2x minus 1 equals, and then just like punch that into your calculator. So log of 50 divided by log of 1.2, and then you get 21.456, and you add 1, you get 22.456, and then divide by 2, and you get 11.228. Okay, so how do ratios of logs in different bases compare? Okay, so let's do this. Log base 2 of 32 we know is 5, because 2 to the 5th is 32, and log base 2 of 4 is 2. So it's 2.5. Let's figure out this one. Log of 32 over log of 4. Log of 32. 2.5. That's interesting. So, other than their bases, these problems are the same, but they have the same answer. So it says, what do you know about your answers part being Same answers, even though different bases. So change log base 2 of 7 into a log range. So basically you can, doesn't need to be log base 10. You can choose any base. So log base 5, for example, and then you can use a change of base formula. So remember, 2 was the base on there, so now it's the bottom of them, and then 7 there, and then that can be any base that you want. So it said base of 5, but it could be any base. Okay, find inverse functions of the following function. So switch x and y, solve for y. So add 2, divide by 3, you get 1/3 x plus 2/3. Switch x and y, multiply by 4, and subtract 1. Okay, switch x and y, subtract 1, and then cube root both sides. So y equals the cube root of x minus 1. Okay, it says, given the function f of x equals 2 plus square root of x, make a complete graph of y equals f of x and state the domain and range. Okay, 2 is going to be my starting point, because that's what makes the inside 0, and then 0 plus 2 is there, and then basically you want to figure out what numbers make your inside like square numbers. So like 2, that will give you 3, and then 5 gives you the square root of 4, which is 2 plus 2 is 4, and then 10 gives you the square root of 9 plus 3 is 5, so forth. So 5, 4 is kind of the last point that fits on here, so you graph that. The domain is x is greater than or equal to 1, and the range is y is greater than or equal to 2. So let's determine the equation for f inverse, that is the inverse of f. So here's our function, switch x and y, and then subtract 2, square both sides, then add 1. And then the appropriate domain and range would be like where they switch. So x is greater than or equal to 2, and the range is y is greater than or equal to 1. So 2, 1 is the starting point. This is f, and this is f inverse. Okay. Alright, it says, state the domain range of the graph. Does this graph represent the function? So, the domain is, so as far left is negative 4, and as far right is 3, but it's not equal to 3, but it's equal to 4. And the range is as far low as negative 5, and as high as 5. Right, you can kind of see if like you draw like a box, like where is the top, right? It's at y equals 5. Where's the bottom? Y equals negative 5. This is x equals negative 4. This is x equals 3. draw the inverse is an inverse a function. So this is a function. Now to draw the inverse, you just kind of plot the other point. So 3, -1, you plot -1, 3. And then 0, -5, you plot -5, 0. And then -3, 5, you plot 5, -3. And then -4, 2, you plot 2, -4. So let's see. That doesn't look right. Looks terrible. That's not right. There we go. And so there's my best drawing. Sorry about that. And the inverse is not a function. Does not pass the vertical line test. State the domain and range of the inverse. Well, the domain and range would just be switched. So -5 to 5 and -4 to 3. Okay, and then use the definition of logarithm to solve each of the following without a calculator. So you just really need to rewrite these. So you have 8 to the x equals 64. 8 squared is 64. So x is 2. 9 to the 1/2 is x. So that's the square root of 9 equals x. So x equals 3. Here 3 to the x equals 3 to the 4th. Or you can just like cancel those. You get x equals 4. And then here those cancel and you get x equals 4. Alright, hope you enjoyed the video. Hope it was helpful.